So in this example here, we're dealing with a standard raffle, whether that be a community raffle or one of the bigger ones like the Hospitals or Regina Home Lottery, the Saskatchewan Rough Riders Lottery, any of those big lotteries where you buy a ticket and there's a certain number of prizes to be given away. The way that these lotteries work is that whenever your ticket gets drawn for whichever prize, your name has to get put back in the drum to be drawn for every other prize. So in reality, it's possible that you could win every single prize. However, that would be extremely unlikely because your probability of winning one prize would be likely pretty low. Even if there's only 100 tickets and you bought one ticket, you have a 1% chance of winning that first prize and a 1% chance of winning every other prize. Start multiplying those together and your chances become very slim of winning more than one prize, let alone all of them. So this raffle happens to have 1,000 tickets. There's going to be 2 draws, first for the grand prize, second for the consolation, and after each draw the winning ticket gets put back in again, so it could be won again. What Max has done, Max has bought 5 tickets, and I want the probability that he will win at least one prize. So at least one prize means he could win the grand prize, he could win the consolation, or he could win both. So let's deal with those probabilities. Well, to win just the grand prize, he would have to win on the first ticket drawn and then lose on the second ticket drawn. His probability of winning, well, he has 5 tickets, so 5 possible draws could get him a win out of 1,000. To lose on the second, there would have to be 1 out of 995 tickets that got drawn that would make him lose out of 1,000 tickets in total. Yes, it's 1,000 tickets because Max's ticket gets put back in. Multiply that together, and we get that it's 0.4975%. We can do the same type of calculation to determine his chances of winning just the consolation prize. To do that, he would have to lose at the grand prize draw, but then win at the consolation. To lose the grand prize, any of the 995 tickets that don't belong to Max would have to get picked out of the 1,000 in the drum. For him to win on the consolation prize, he'd have to have one of his 5 tickets out of 1,000 get drawn. Multiply those together, and again, we get 0.4975%. Now, we haven't taken into account the fact that Max might win both. As small as that probability might be, we do need to take that into account. So, the probability of Max winning both prizes means he would have to win and then win again. Well, the probability of him winning is 5 out of 1,000 each time. Multiply those together, we get his probability of winning both would be 0.0025%. So then his total probability of winning at least one prize, well, grand prize was 0.4975%. Consolation prize was 0.4975%. And both prizes was 0.0025%, which means that Max has a 0.9975% chance of winning at least one prize. Basically 1%. There's another way we could think about this. If we think of this as what is the probability of Max losing both prizes, everything else that we didn't consider in that case would be what happens when Max wins one or both. So to lose both, Max would have to lose the first one, so any of his $9.95 tickets that don't belong to him out of 1,000. And then to lose the second prize, any of the $9.95 out of 1,000 that don't belong to him again, would mean that there is a 99.0025% chance that Max loses both. So therefore, the chances of winning one prize, well, we know all of the chances have to add up to 100%. And if we subtract off the chances of him losing both, we get to the same 0.9975%. We just get there in a bit of a different way. Either way is completely valid. One involves a little bit of higher level thinking, one involves a little bit more brute force.